Has everybody had a chance to look over their answers? There's 11 through 14. All triangles add up to 180 degrees, yes. Yesterday, when we talked about congruent figures, we said you had to have all of the sides and all of the angles. Today, we are going to talk about how you can prove two triangles are congruent without having three sets of sides and three sets of angles. So what you see at the top was the definition that we talked about yesterday. It said the definition of congruent triangle states that you need 6 pairs of congruent corresponding parts. 3 sets of sides, 3 sets of angles. And today we're going to say you only need certain pairs of congruent corresponding parts. And the first one that we're going to talk about is side, side, side congruence. And you won't ever have to write this out. All you actually end up writing are the 3 letters, SSS. If 3 sides of one triangle are congruent to 3 sides of another triangle, the 2 triangles are in fact congruent to each other. Once I can see that they're congruent, I could write a congruent statement. The order of the first triangle does not matter. I'm going to write ABC. The order of the second triangle does matter because remember, the corresponding parts have to be lined up. So, if I went A, B, C, I went down a side that had 3 marks, down the side that went have 2 marks, and then I would come back around to the 1. I've got to state this one in the same order. So how do I want to state it? I want to state X, Z, Y. And I know that these 2 triangles are congruent by side, side, side. Once I know they're congruent, what can you tell me about some of their angles? The angles are also what? Congruent. Angle A would be the same as angle X. Angle B would be the same as angle Z. Angle C would be the same as angle Y. But instead of having to have all those angles to start with, we can do it with just this side, side, side congruency. Questions about this theorem? Okay. Next, if the angles of one triangle are congruent to the angles of another triangle, the triangles are not necessarily congruent. If I take a look at P, Q, and R, and then I look at L, N, M, I have 2 angles of one triangle congruent to 2 angles of another. What can you tell me about angle P compared to angle L? It's what? It's congruent. I know that angle P is congruent to angle L by the third angle theorem. But do I know that the 2 triangles are congruent? No. And an example of that is in the picture below. Angle, 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 congruency is not guaranteeing triangle congruence. If you take a look, they've drawn a smaller one on the inside, and it's easy to see that if all these angles are the same, that the 2 triangles don't necessarily have to be the same. It works with side, 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 but does not work with angle, angle, angle. Everybody okay? Okay. Now we're going to talk about what it means to be an included angle. I'm going to pick two sides in this triangle. Let's say I pick XW and I pick WY. And we're looking for the included angle. Which angle do you think it is? It is angle W. This angle would be included. If it's caught between those two sides, or you might even look at it and say it was formed by those two sides. Here's this side, here's this side. That angle was formed by those two sides. It's included between them. Jesse.
So like say we switch it and put the two lines on X and Y.
Okay, so let's do that. Let's switch it. Where do you want me to put the lines?
Two there.
Two here?
Yep. And then one where you had last time.
And here. What's included?
Would it be the X now?
X is included.
So you get a pick basically.
What's that?
So you like get a pick basically. Like if you have two of those.
It depends on what they've given you in the figure. And you'll see that more clearly here in a minute when we start doing examples. But we need to know what an included angle is in order to talk about the next way to prove triangles are congruent. The other method to prove a triangle congruent is side angle side. Again, you'll never have to write out the words, just SAS. Notice that the angle is stuck between the two sides. In other words, if two sides and the included angle of a triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So if I look at my picture up here, I've got two sides congruent and this angle that's included. I have two sides that are congruent and the included angle. So I could write a congruence statement. Again, the order of the first triangle makes no difference. I'm going to say M, N, L. The order that the second one is in now matters because corresponding parts have to be lined up. I went from one mark on a side to the angle to two marks. So I'm got to go P, R, Q in my other triangle. And I know these two triangles are congruent by side angle side. So yesterday to state two things were congruent, we had to have all the angles and all the sides. Today, if we're working with triangles, I can do side, 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 or I can do side angle side, where that angle is the included angle between the two sides. Let's take a look at some examples, and Jesse, I think this will answer your other question about, do I just get to pick it? Here they're asking me, are these congruent? And if they are, give them one of these reasons, either side, 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 or side angle side. Well, if I take a look at example 1, I see I have a set of sides. I have a pair of angles that I know are congruent because they're both 90 degrees. What else would I be able to determine in this figure? Take a look. Here's this triangle. It has a shared side, doesn't it? Everybody see it? It has a shared side. If it has a shared side, obviously that side is congruent to itself. So if I look at it from the pink triangle, or if I look at it in the yellow triangle, now I have a side, an angle, and a side, and the angle is included. I have a side, an angle, and a side, and that angle is included. So I can state that these are congruent by side, angle, side. Example 2, can I state that these are congruent? Yes, this one would be side, side, side. Example 3, can I state that these are congruent? No. They gave me an angle, and a side, and I don't have anything that does that at this point. Everybody understand this, what these questions are asking? Next set of examples then. Here they're telling you, state what additional information would be required to state that the triangles are congruent by a particular reason. This one is saying side, angle, side. I'm missing an angle, right? I have this shared side. BC is obviously the same in both triangles. So I'd need this angle, and I'd need this angle. So they want you to state that angle name. I'd need angle ACB. Why can't I call it angle C? There's more than one angle there. And again, I couldn't call this angle B. Why? More than one angle. It would have to be congruent to angle D, B, C. So they're looking for that piece of additional information. They'd had to have given me that in order to state that these two triangles are congruent. Example 5. They want me to state that the two triangles are congruent by side, side, side. I noticed they gave me two sets of sides, so I must need the other side. So I must need segment XY being congruent to segment MN. Example 6, side, angle, side. They gave me a side, they gave me an angle. Which side would I need in this figure? Would I need FE or would I need EG? I've got to have FE so that the angle is what? Included. It's got to be caught between them. So it's FE. Which side would I need over here? KJ or JL? I need KJ. And I need KJ so that the angle is included. It's stuck between those two sides. Everybody okay? Your assignment is those two worksheets. I promise you it seems like a lot, but they shouldn't take probably more than 10 minutes to do all of them.